Okay, YouTube, in my next set of videos is going to be moving through rational functions. So in this video, we're going to define what we mean by rational functions and also make a note about the domain of a rational function. So we'll go ahead and start with this. Rational functions are quotients, okay, and they're quotients of polynomial functions specifically. So we're pros with polynomials. Really, a rational function here like f of x is just what you get when you have a ratio of two polynomials, okay? So a rational function is a ratio of two polynomials, essentially. Or we say p and q are polynomial functions. And by the way, we make a note here that q of x is not allowed to be 0. And the reason why is simply because we cannot divide a ratio by 0. So we say the domain of a rational function is the set of all real numbers except for the x values that make the denominator 0. So for example, this is provided here. It says our p of x, or our numerator polynomial, over our denominator polynomial. You'll notice that this is already in a factored form. So if we were to set the denominator equal to 0 and solve it by factoring, setting this equal to 0, we certainly know that because of our factor theorem that we would get zeros x equals 0, positive 2, and negative 5, which is certainly what we got provided here. So we would say the domain is all real numbers except for these right here. And so let's go ahead and take a look at what we see here with these three polynomials on the right. These actually, take that back, it's not polynomials, these three rational functions that we see on the right here. So with respect to finding the domain of each rational function, one rule that we want to make sure we write here is this. We always start by factor the numerator and the denominator. And you can put a lot more detailed notes than I can put because my handwriting is bad on this thing. But factor the numerator and denominator, and then I'm going to write simplify if possible. The idea is that sometimes, if possible, sometimes we get a function that simplifies if it's rational, as a common factor on top and bottom. So I notice the top here is a difference of two squares. So that factors into x plus 5, x minus 5. And this is all over x minus 5. Now here's the deal. The x minus 5's cancel, and I get left with x plus 5. But with respect to the denominator, the really crazy thing is this. This right here is going to give us the domain. Basically, even though the x minus 5 canceled, we're still going to take our denominator value here and factor it and set it equal to 0 and solve it. So now if we set x minus 5 equal to 0, we would learn that x equaling 5 would cause our function to be undefined. So we would say that the domain of this function, we'll go and write our domain here, is negative infinity up to 5 and not including 5 in union with 5 to infinity. So all real numbers except for 5, essentially. And so we could also write that, by the way, in set builder notation as all x values such that x is not allowed to be equal to 5. All of those numbers are in our domain. Okay, so set builder and interval. Taking a look at this next problem here, we're going to start by factoring the top and the bottom. The top doesn't factor. The bottom certainly does factor. This is our difference of squares again. X squared minus 25 is x plus 5x minus 5. So setting this equal to 0. Set equal to 0 and solve. Let's go find the x values that would cause our denominator to be 0. And I would say that our x values will be plus or minus 5 when we set these equal to 0. So again, the domain, we want to state the domain here. We would say negative infinity up to negative 5, and then from negative 5 to positive 5, and then 5 to infinity, and I forgot my union symbol here, apologize, but we'd say this is our domain here. And then for this last one here, the interesting thing is the top and the bottom, neither of them factor. So we would say that the denominator, I'm going to go ahead and take this. Just because it doesn't factor doesn't mean I can't set it equal to 0 and solve, like we said here, like we said here, and like we said here. So what we're going to do is set this equal to 0 and solve. I notice I could solve this using square roots, and when I take the square root of both sides here, look what I end up with. I get x equals I times the square root of positive 25, or in other words, I get x equals plus or minus 5i. What I want to comment on is this is not real. So we would say that the domain is all real numbers, or negative infinity to infinity, because there are no real x values that when I plug them in cause that denominator to ever be 0. But that's what a rational function is a ratio of two polynomials, and we say that the domain is always all real numbers except for where the denominator might equal 0. Cheers.